Right, so the first thing that I want to do here is to talk about finding the least common multiple of numbers. There's actual commands for this that are located on the calculator. Again, you can kind of follow the instructions if you have it on your own. But if you go into this math catalog, so the math catalog is accessible by hitting second 5. Okay, and the least common multiple is located under this number option. So go ahead and like look at the different values that you have in there. So this is where absolute value is located as well. Okay, and if you scroll until you find the least common multiple, you can then just include two numbers, and it has to be exactly two numbers. So if you happen to have, like, instead of 3 numbers, you'd have to do one group of 2, then a second group of 2, and kind of work your way through in that regard. But if you find these, this is going to find the smallest number that's a multiple of both 42 and 35. Okay, we talked about how to do this by hand in Chapter 1 by breaking it down into individual factors or by forming that table where we kind of work through them. But if you wanted to find this with ti89, you can use this command. Okay, so do the same thing here really quickly with 12 and 9. Should be pretty straightforward. Normally, I would just delete these two numbers and replace them, but I'm going to go through all the steps again. Okay, so I mentioned that it's located in this math catalog, so second 5 to open that, option 1, numbers, and then find it. You can also just alpha lock. If you hit this white button twice, notice the first time I hit it, this little A appears right here. If I hit it a second time, that A gets kind of highlighted. Now it's in alpha lock mode. So if I just type in LCM, so if I remember the code or the keys for it, I can just type it in directly, okay, and then I list my two numbers, 12, 9, close it off, and hit enter. And so the least common multiple of the smallest number that's a multiple of both 12 and 9 would be 36. Okay. All right. Next, again, I have the instructions to kind of walk you through what I'm going to show on the calculator. But when you are evaluating functions, there's a number of different ways you can do this. So if all you have is just one single expression, what you could do is if you're substituting in a 6 for the b and a 1 for the z's, you could, if you wanted to, like physically substitute in those values as you type in your expression. But there's another way that you can do this using what's called the with key. The with key is the key that allows you to evaluate with a given variable being set equal to something. And that is here, if you type this equation or this expression using the variables that it provides, so here b squared plus 5. Now remember, your calculator doesn't understand that if you put bz, it wouldn't know that those are two separate things. It would think that that was just one variable called bz. So you do need to explicitly multiply here. So I have 5 times b times z, and then plus the z squared. So if you type in your expression, you can use the with key, which is this vertical bar right here, right below the equal sign to the left of the 7. What you can then do is you can set the values you want to express or set equal to a given number. So if I want b to equal 6, I would type that in right here. So the with key, and then I'd put b equals 6. Next, you're going to have to type and, because I have multiple variables here. If this is the only one you needed to evaluate, you'd be done and you can hit enter and it would evaluate that. Since we have two variables here, I'm going to hit this alpha lock key again. And I'm going to use a space. Remember this underscore right here, the shift change of sign is the underscore, the space button. And then I'm going to type the word and underscore, get that space again. Then I can deselect my alpha keys. And I'm going to put my second variable, which is z equals 1. So if I make that as my substitution, now the calculator is going to take this whole expression and it's going to evaluate that with b equals 6 and z equal to 1. And when I do that, I get my answer here of 67. Okay, so try that same thing with the second problem. Again, if you prefer, you can just type in a 5 instead of the C and a 4 instead of the A's as you type these. This is something that's especially useful if you're being asked, like next year, if you are allowed to use your calculator. But if you're evaluating a table for some different values, this allows you to write in one expression and then keep changing what the variable is set equal to and evaluate it that way. As always, you could change the C to an X and the A to a Y to make it easier to plug in variables. However, I'm just showing you how to do this so that you can do like it's exactly as it appears. Okay. So here we have C squared plus CA plus A squared. Again, notice I explicitly multiplied C and A, otherwise it won't know that you have two variables. Okay. I'm going to let C equal 5, and again alpha lock space, type the word AND, space again, deselect the alpha key, and I'm going to let A equal 4. And when I evaluate this, I get my answer to be 61. All right, so that's using the with key. You can embed with keys into solve feature as well. Okay. And also, so if you ever need to solve for something, you can use that with key. This would be something that you could have incorporated into in the Precalc 5 when you're writing a polynomial function given zeros, okay, and you were asked to expand everything. You can do the expansion and then copy. Let x equal whatever the x coordinate was that you're testing the points for. So you can use that embedded in a solve feature also. All right, next is calculating absolute value. I showed you where it was here in the math catalog. And the biggest mistake is to think that the with key is absolute values. Even though it looks like it is, it doesn't represent that. It's ABS is the absolute value command. And so if you're going to type absolute value for this, again, if you want to do it, enter it directly, you can go into the math catalog. So second 5, underneath number, choose ABS. And every time there's absolute values, you're going to need to type this and close it off with the parentheses. So here I get 4 minus 4 times 5. I'm going to close that off. So there's that whole first absolute value, and then minus. I'm going to type it again. Now, the other way that you can do it, if you don't want to go into the math catalog, is just alpha lock and type ABS, if you remember what the command is. And then you can take 4 times 3 and subtract 6, close off that absolute value. Now, when I hit enter, the display up above will actually show the absolute value symbols. Okay, but the ABS is how you have to enter them. So here you can kind of confirm, is this written the way I was expecting it to be? Does it look like what the problem's showing? Yes, when I am looking at that, I wind up with 10 for my answer in that expression. All right, I want you to try the second problem on your own, see if you can evaluate that absolute value. So again, I go into my math catalog, after number, scroll down to absolute value, ABS, type in my first expression, 7 minus 4 times 5, close that off, minus, again, I'm going to access it the same way, math catalog, choose absolute value. I get 7 times 3 minus 5, close that off. Double check, make sure that this looks like what I'm expecting it to look like. It does. My answer, -3 for the solution. Okay. All right, again, if you have any questions, just let me know or ask me. All right. So next is the converting to a rational form. Right. So if you recall, when we did this by hand, we wrote where we can express all the digits, 84612, divide by 10 to the power of the number of digits that fall after the decimal 3. So if you just typed this into your calculator, you could simplify and get your answer. And so this is just using the same rules that we actually used when we talked about this in class. So 21,153 all over 250 is the solution when you simplify this. But there is another way to do this, and again, you can see it here on the notes. Okay, but you can also, in that math catalog, underneath number, you see this option for exact, the very first option. And what exact is going to do is it's going to take a decimal, okay, an approximation, and then it's going to convert that into an exact answer. So if we type what we have, 84.612, into this, if it's a terminating decimal, that's all you need to do. Okay? So if you have that terminating decimal, close the parentheses, okay, and it will give you that rational form. Okay? So this confirms what we just did. Okay, if it is something that is not, if it's a repeating decimal, okay, then you have to add an extra step to this, which you're going to see here in this next, the next slide. Okay, so actually try the, oops. Yeah, so let's take a look at this first example here, and then I'll have you try the next one on your own. Okay. So if you are looking at these repeating decimals, and you're trying to find what is the exact form of this decimal approximation, what you're going to do is, again, access the exact, which is the math catalog under option choose exact. You're going to type in the decimal. Okay, and when you do this, what you're going to do is you're going to repeat it a few times. Okay? And so for me, I'm going to repeat the pattern like 2 or 3 times. Okay, and then what you're going to do is you type the place value of the last digit that you typed in here. So this last digit was 0.001. Okay, so when I place that in there and then close it off, it's going to write this in its rational form, which is, in this case, 25 over 9. You can double check it and verify, okay, which you should do. Okay, is 25 over 9 going to give us this answer? And if you take 25, divide by 9, put a decimal point in your display if you're in auto mode, and it'll give you an answer in that approximate or decimal form. Or you can hit this diamond button before you hit enter, and it'll give you that. And so here, is that 2.77 repeating? Yes. Okay. All right. So try with the next example on your own and see if you can come up with the rational form for 612.84 repeating. Now remember, you guys are still going to need to be able to do these by hand, okay, for your final. Okay, I'm just showing you how to use your calculators in case you get to use them on anything. Access Math Catalog, choose exact, type in the decimal, 612.8484. I'm just going to repeat that twice. So I'm going to put this in at 0.0001. And when I do, it gives me a rational form. Actually, let me see if I need to repeat this one more time. 6. There we go. Okay, so do repeat it 3 times. Okay, so repeat whatever your pattern is 3 times, and that will give you your answer. Let's double check and make sure that this is correct. Put a decimal in to display, and here you do see that it fits the pattern that we're looking for. Okay, so 20,224 all over 33 would be the answer. So that is the material from Chapter 1 that we covered and how you can do those types of questions on a TI-89. All right. The next the next chapter, Chapter 2, and let's look at some of the ways that we were working through problems here. So one is to take a given formula and isolate a specific variable from it. Okay, so if this is the case, what you're going to do is just use the solve feature of the calculator. So that's located in the F2 algebra tabs. Solve, you're going to write your equation exactly as it appears. Okay, when I write this, if you need to, if you're writing capital letters, you use this little up arrow key. You can see that it highlights a little arrow pointing up here. That will give you a capital letter. Okay, and then continue with your fraction, or with your equation. Now, moving from a number to a variable, like p, the calculator does understand that that's taking 1/2 times p. I went ahead and explicitly multiplied anyway, because if I put PL, the calculator would think PL is just one single name for, or the name for a single variable, not two separate variables being multiplied. So again, I have to explicitly multiply. Type that in, plus, and again, I'll use my capital B here. Okay, and I'm going to solve this for L and close it off. So what I've done here is I've written my equation. I identify with a comma L which variable I'm going to isolate, and when I hit solve or enter, it will give me the equation. Let me see here. Oops. The only reason, like this has A and B. Do you remember when we did matrices? I mean, my calculator has A and B stored as a matrix. So what I'm going to do here really quickly is I'm going to delete my matrices. The way that you can delete anything that you've saved in a variable before is to access this cleanup tab, F6, so second F1, and clear A to Z. So this is going to clear everything that I've saved as A and B. And so now when I actually do this without having to change anything, it'll give me the answer I'm looking for. Again, it just had matrices, two different matrices stored as A and B. Okay, so here is my answer, 2 times A minus B all over P. Notice it didn't register A and B as capitals. So that just means if you do have something with multiple variables, make sure that are capitalized versus non-capitalized. Make sure when you type it into your ti89 that you do have to change one of those if that is the case. All right, so try the second equation here on your own. Okay. The most common mistake that's made in isolating quantities and using the solve feature with multiple variables is to not explicitly multiply. Okay. And so if you ever see that it's not solving for the variable that you want, okay, or when you look in there that it has like variables side to side next to each other without the dot multiplication symbol, then that's likely what you did. Okay, so the solve feature, algebra, the F2 algebra tab, write my equation. Again, I can imply multiplication after a number, so 7 and then parentheses. It does register that that's 7 times. R plus 2C, again, the same thing. I don't have to explicitly multiply between the 2 and the C. It understands that relationship. But this AR, I do. If I, again, just wrote AR, it would think that's one single variable representing a single individual quantity. Here I'm looking to solve for R. And so when I do, I get my answer to be 14C plus 15 all over A minus 7. All right, a couple more slides here with the Chapter 2 materials, but they are mostly having to do with the solve feature. Okay, so the next is using the solve feature for inequalities. This is a possibility also. So when you are solving for this, you're just going to do each individual when you type this in, if you have an and or an or, you can just type those in to your expression. So if I hit the F2 algebra tab, solve, okay, 3y, type your inequality, plus 12. Notice the inequality symbols are down here, less than and greater than. So we hit blue, 0 is less than. Make sure you use the change of sign key for a negative number. If you plug in this subtraction key, it'll give you an error there. Okay, and then I have a second solve here, so I do need to go into alpha mode. So lock the alpha key, hit space, type in my word or, the compound inequality. And now I can write my second inequality, 3y plus 12. Now notice this says greater than or equal to. There's two ways that I can express that. I can click on greater than and then follow that up with an equal to. So I can do it as two separate symbols like this. You can also use diamond. If you hit diamond and then this inequality, notice it puts that greater than or equal to in just one keystroke. So either one is fine, whichever one you want to choose. Okay, and then you tell it what you want to solve for. We're solving for y in this case. Close off our solve feature. And when we do, we get our answer. Notice it gives us this compound solution that y is greater than or equal to 0, or y is less than negative 14 over 3. Okay, so this one, depending on how you are being asked to enter your answer, you may need to enter it in interval notation. So that is up to you to be able to take this inequality form and write it as interval notation. Notice I have a negative 14 thirds is less than 0. Negative 14 thirds goes to the left. Here, y is less than that. Y is greater than or equal to the 0, so it's an equal sign, which gives you a bracket there. And so this sets up the inequality, or the interval notation that you would put negative infinity to negative 14 thirds with parentheses around both, bracket at 0 to infinity with the union of sets symbol to indicate your union of sets. So the ors tend to represent these unbounded intervals. Okay, the ands tend to represent the intervals that are sort of sandwiched in between. So when we look at this first inequality, it's just a single linear inequality. So if we hit the solve feature, F2, type in your inequality, so negative 6x minus 13, less than or equal to, so I'm going to use this the green diamond. And then less than gives me that symbol all at once, or you can just type it in as you would speak it, less than and then equal to 1 minus 4x. And we're going to solve for x in this case, close off the solve feature, and we get our answer to be x is greater than or equal to negative 7. So this is our answer. It's easy to express this. We have one critical point. Arrow points to the right. It does have an equal sign, so we put in the equals to create that bracket. And so you get negative 7 to infinity, always a parentheses at the infinity. We have a bracket at the negative 7. And so that would be your solution. Okay, and then the last example here. A couple things to notice here. You could type this in and separate it with an and. That's fine to do. But if you do recognize that both of these expressions are the exact same, 2a minus 11. So if I type in this inequality, less than or equal to 0, and I type in this inequality here, notice that it opens to the 2a minus 11, and then the negative 16 is where the point of that inequality points. So I could express this as one single inequality like this. So when I type this, I could either type each one separately and use the and to separate them, or I can rewrite it in this form for the, and I'm going to use, the less than or equal to. This time I'm going to go ahead and type it as two separate ones. So less than or equal to, and I get 2a. Calculator understands that implied multiplication there, minus 11. And I'll do the same thing, less than or equal to 0. and I'm going to solve for A. So comma A tells the calculator what to solve for. So last thing, let's jump down to the equation then. And try solving the equation by entering the same thing but with the equal sign, and it should work for this calculator as well. F2 algebra tab, select solve, -2 times, again, I'm going to go ahead and just type the word ABS. It's a pretty simple string to type. Here that gives us V's. I'll go ahead and use V's, although I might have been tempted to change that to an X to make it easier to type. And that's all equal to -9. Make sure you use the change of sign key and identify the variable you want to solve for. And when you do this, you get your answer. Here it will be -5 and -11 would be your solutions.